Hi everyone, in this presentation, I'm going to explain how TCP ensures reliable data transmission, which is a key concept in transport layer of computer networks. So basically, when we send data over the internet, it doesn't go as one single piece. It is broken down into smaller parts and TCP makes sure that all parts reach correctly in order and without loss. Before going deeper, there are two main protocols in transport layer, TCP and UDP. TCP stands for Transmission Control Protocol. TCP is reliable, connection oriented and ensures delivery. Whereas, on other hand, UDP, User Datagram Protocol, is faster but does not guarantee delivery. So, in this presentation, we focus on TCP because reliability is very important in applications like file transfer, emails, and web browsing. Before we understand how TCP works, let's clearly understand what TCP actually is. So, as I said before, TCP stands for Transmission Control Protocol. It is a transport layer protocol, which means it operates between application layer and the network layer in a computer network. The main role of TCP is to ensure reliable communication between two devices over a network. Now, what does reliable really mean here? It means the data should be delivered completely in the correct order, without duplication, and without loss. This is very important because we use applications like web browsing, email, or file transfer. Even a small loss of data can cause errors. So, TCP takes responsibility for managing this entire process. Another important feature of TCP is that it is connection oriented. This means that before any data is sent, a connection must be established between the sender and the receiver. You can think of it like making a phone call first before starting a conversation. Once the connection is established, data transfer begins in a controlled and organized way. TCP also breaks large data into smaller segments. Why is this needed? Because sending large data all at once is inefficient and risky. So, TCP divides it into smaller parts, send them separately, and then reassembles them correctly at the destination or you can say the receiver side. Each of these segments is given in a sequence number. This helps in maintaining the correct order of data even if packet arrives in a different order due to network conditions. TCP also ensures error detection. If any data is corrupted or lost during the transmission, TCP can identify the issue and request retransmission. So, instead of the application worrying about the errors, TCP handles everything at the transport layer itself. Another key role of TCP is flow control. It makes sure that the sender does not send data too fast for the receiver to handle. This prevents system overload. Similarly, TCP also handles congestion control, which manages the traffic in the network to avoid delays and packet loss. So, overall, TCP acts like a smart manager that controls connection, data transfer, error handling, and traffic control. All of this ensures that communication between devices is smooth and reliable. That's why TCP is widely used in most internet applications where accuracy and reliability are the critical aspects. Let's move further. Now let's understand how TCP connection starts. This is called three-way handshake. Step 1. The client sends an SYN message to the server saying, I want to connect. The server replies with SYN ACK, meaning I received your request and I am ready to connect. Step 3. The client sends ACK back confirming the connection. After this, connection is established. So this is the whole procedure to establish the connection before. Once the connection is established, data is sent in small segments. Each segment has a sequence number. So TCP does not send an entire file or message as one block. As I mentioned previously, it breaks the data into smaller units. Those units are called segments, and each is tagged with a sequence number. This helps the receiver to arrange data in correct order even if packets arrive out of the order. I have already explained all these points in the previous slide. Now, after receiving the data, the receiver sends an acknowledgement, also called ACK. For example, imagine if it, if it receives data up to sequence number 100, it sends ACK 101, meaning it expects the next data from 101. This ensures that sender knows what has been received already. Now imagine if any packet is lost, what will happen? TCP will detect it. How? If the sender does not receive an acknowledgement within a certain time, it retransmits the packet. This is how TCP ensures reliability even in unstable networks. Here one more term comes out is RTO, retransmission timeout. It is dynamically calculated using round trip time RTT. If RTT is high, RTO grows to avoid premature retransmissions. Flow control. Flow control prevents the sender from overwhelming the receiver. It uses something called window size. This window size tells the sender how much data it can send at a time. This is called flow control. Basically means controlling the amount of data that could be sent at a time. Congestion control. Congestion control handles traffic in the network. If too many packets are sent, network becomes slow. So TCP reduces sending rate to avoid congestion. You can think of TCP like sending parcels with tracking. Each parcel has a number. You get confirmation when it's delivered. And if something is lost, it is sent again. So overall, TCP ensures reliable communication. How? Using connection setup, sequence numbers, acknowledgements, retransmissions, flow and congestion control. This makes TCP one of the most important protocols in network. Thank you.